Hello viewers, welcome back. Today I am showing how to run MATLAB Simulink. I use in MATLAB Simulink 2024B model, and today we discuss hybrid renewable energy system in simulation. I use here PV and wind and lead acid battery. Here we start from PV subsystem. We take PV array. This is PV panel. We take module, Jinko, solar, and input parallel string 15 and series connected module per string 15. We can also see we can apply this and OK. Then we can see plot. Here we can see plot is array type Jinko Solar Co Limited 15 series module 15 parallel. This is current. This is we take 25 degrees Celsius and this is power. Now we connected with irradiance. Here we take irradiance 1000, input 1000 and apply and then OK. Then we connected 25 degrees Celsius temperature, and this block parameter is the constant. We can find from library browser and we can take from this, and this irradiance output we can take go to. Then we connected with the bus. This is bus selector, and we take voltage and current with connected go to. Then we connected also with the RC. We can find from library browser, and we connected series with RL and apply and OK. We connected all, and we also connected parallel IGBT diode, and here we connected gate with port hub and observe. Here we can see this is generator, convert DC to DC, and here we connected from D gate. Here D gate is, and we connected with the gate. Okay, and we connected with R. It is ground. Then we connected with diode in series, and we connected with C booster converter. Here we connected parallel load connection, and this is my PV subsystem. And here we can see scope all, and we first of all we go to MPPT subsystem. Here we take voltage PV output and current PV output, and we can take here from this. Okay, input the function, port have an observe function. Here we take pandu function D, and we take 0.7 D ref, D previous voltage 0.7, voltage previous voltage 190, power previous 2000. This is metal function we input in MPPT, and this is gate. Here we connected from this gate. Now this is as booster, we connected with D boost, and this is generator. Here we can see as booster. This is D gate, we connected as booster, and we connected with the generator, and we connected IGBT in gate. Here is a power of PV array, and we connected, we take product, and we connected current PV array, PV output, and voltage PV output. Here we connected to the product and output here, and go to, we connected output to the go to, and it is scope, we connected a scope for we can see output power, and we connected all scope in here. It is temperature, this is voltage, this is current, this is voltage, this is I boost, current boost, this is power. This is all we connected, I boost, voltage measurement, and this is voltage bus, and we here connected with a common DC bus. Now we also explain wind subsystem. We take wind turbine this is wind turbine, and here we connect it with a speed generator. And now here first of all we take wind turbine, then we connect it with the permanent magnet synchronous machine. This is called also permanent magnet synchronous generator. We connect it to with the PMSG, and we connected with pitch angle. Pitch angle is 0. Oh no, we take a 3, pitch angle 3. Okay, and we take wind speed 1000. Okay, then here we connected bus selector bus, and we connect with the generator speed, and we also connect with gain. This is gain for speed, and this is output scope. We can see from this, and we connected also display. Now we connected with the 3-phase VI measurement. This is for DC elements, and we connected phase A to A and B to B, C to C, and we connected a scope for measuring voltage and current, and we connect also diode. This is diode for all phase A, B, C. This is twice diode, and connected with the resistor, and this is voltage measurement, and we can see we can connect it with a scope, and this is wind voltage measurement. This is a display, and we connected with the ground. All connected need to ground, and this voltage, this line is connected with the DC common bus, and here we connected with DC link capacitor, and this is the power storage. We take here lead acid battery, and this is and we connected with the reference ground, and output we connected with bus selector, and we can see from voltage, current, and so stage of charge, and this is display. We can see from voltage and current, and this is state of charge. So we can see from this. We take a 1D lookup table, and from connected with the scope, and this is display. We can see average rated power, This is for all scope. This is power, this is current measurement, and this is current, and this is voltage measurement, and this is voltage, and this is irradiance. Now we can see, and here we can see wind turbine output, and here we can see speed, rotor speed. This is voltage measurement, all wind turbine voltage, and here we can see battery voltage and current.